Another great way to challenge yourself into really learning Fusion 360's options when it comes to T-splines modeling is to explore the idea of taking a closed primitive, opening it up to create a different type of geometry. A quad ball is a very flexible primitive. In this case, what I want to do is just rough one into place, rotate it a little bit, and then remove half of the quad ball to create a dish. Now that I have my model opened up, I'm going to go ahead and use Edit Form and other tools along with Symmetry to make modifications to this to create a classic style lounge seat. By using basic push and pull and rotate tools, the same as we've been using all along, you can see how this quad ball is transformed into something radically different in no time at all. For the sake of time, I'm going to speed up this process so you can see the various steps taken in far less time than they took. Once I have my open T-spline form and shape, I can use the Thicken tool to give it depth. In this case, I'll make it 5 millimeters thick, but I want to tell it to go ahead and apply a soft edge all the way around the perimeter. This has essentially made a solid model, or at least a model that will be converted to a solid when I select Finish Form and re-enter the modeling environment. Once I do that, you'll see that other bodies reappear. Now what I need to do is complete a design for mounting my new solid chair to the purchased frame. To do this, I'll simply start a new sketch and project the edges of my mounting pads from the purchased frame. Once that's done, I can go ahead and connect those into any sort of web structure or anything else that I think needs to be in place to make it strong enough to make sure my chair remains safely attached to the base. The flexibility of Fusion 360 allows me to go ahead and finish my sketch and begin to extrude these profiles while my seat is still off. Now if I were just making a standalone body of this, this would be all I would need. I can turn my seat on, see that it's cutting into my seat, but then tell it to go ahead and join. And tell it to join in the best way it possibly can by saying extrude all. You'll see it meets the geometry of my existing seat and stops. I can apply some fillets to make this a better connection and to look better as well. And then smooth the transition between the base and the bottom of the seat. Just for the appearance sake, let's go ahead and apply a little different look. Now I need to export this geometry to a format that I can produce it in. I can export to any standard neutral CAD format, or some CAD formats that are specific to other manufacturers. I can export also directly to Autodesk Inventor, and I can also tell my body to go out to a stereolithography file, an STL file. I'm able to preview the mesh. I'm able to use preset refinement levels to judge how smooth I need the STL file to be. And I can also use custom settings. For example, surface deviation to tell it how flat the face can be away from the curve. I can export out my STL file and produce it in virtually any 3D printer made.